Here's the question then. Question 6. Okay, I've got it summarized here. So let's have a look at it. This quadratic has two equal roots. Show that this. So A, part 1. So the discriminant is 0, isn't it, for two equal roots? B squared must be equal to 4AC. So B squared, this squared, must equal, so I'm going to put minus 4AC equals 0 rather than equal. Minus 4 times A times C, more than one term per bracket, minus 4AC must equal 0. The discriminant is 0 for it to have equal roots. This is squared, of course. 16 squared, k squareds, plus 8, 4k and 4k is 8k, and 1 times 1 is 1, minus 4 lots of k squared, expand this bracket here, minus 5 plus 1 is minus 4k as the middle terms, plus times a minus is minus, 1 times 5 is 5, equals 0, so we end up with then 16k squared, plus 8k, plus 1, expand this, minus 4k squared, minus times minus is a plus, 4 fours is 16, lots of k, and minus times minus is a plus, 4 fives are 20, that needs to equal 0. Okay, 16 minus 4 is 12, lots of k squareds. 8k plus 16k is 24k. And lastly, the 1 plus the 20 is plus 21. There's a 3 common here all the way through. So divide by 3, we get 4k squared. 8k plus 7 equals 0. That's what we wanted to show. Let's have a look. Yep, hence show that there are no real roots, no real values of k such that this is 0. So no real values of k. So this is a quadratic in k. So here, b squared minus 4ac is equal to, let's have a look what it equals, 64. Minus 4 times 4 is 16. 4 times 4 times 7. B squared is 8 squared minus 4 times A, 4 times C, is equal to 64 minus 28 times 4. 28 times 4 is 80, 4 20s, and 4 8s are 32. 80 and 32 is 112, which equals minus 48, which is less than 0. So no real roots. Okay, that's that part done then. That's part 2. Okay, find x satisfying this now for part B. Let's move on to this next part now, B. So we've got 4x squared minus 9x minus 9 is greater than or equal to 0. Let's try and factorize then. Now, 3 3's has got to be. Yeah, it has to be 3 3's. Or it could be 9 1's. Couldn't it? And this could be either 4 1's or 2 2's. But this is odd, so it can't be 2 2's because you get an even product. So 4 1's, I'm going to try 4 1's. This would be minus 12, wouldn't it? This would be plus 3. So I think that should be it, shouldn't it? So let's have a look. 4x squared, so it's only trial and error. Minus 12x plus 3x is minus 9x, that's fine. Plus times minus is a minus, 3 3's are 9. So that looks fine. A little sketch of it here, just to help us see how this inequality is satisfied. It's a quadratic, so it's a U or an N-shaped curve, but it's positive. It has roots at 3. And this has roots at minus, when this is 0, when x is minus 3/4, yeah, minus 3/4. And then it will just come down, like so, go along here, and then come back up So we can clearly now see when is this quadratic. Greater than 0, it would be greater than 0 when it's over here. X is bigger than or equal to 3, because it's greater than or equal to 0. So it's bigger than or equal to 3 rather. Or it could be less than or equal to minus 3/4, couldn't it? And there's our two possible ranges combined.